Hello, welcome to my quick tutorial on how to use the MATLAB One-Stop Shop Particle SEM tool. This tool is useful for analyzing SEM images generated from the Magellan SEM here on Notre Dame's campus. To get started, what I'm going to do is I'm going to take a look at my working directory for MATLAB. So I can see that I'm in this MATLAB One-Stop Shop Particle tool. I've got the particle tool itself, the MATLAB app, two functions, the analyze and the select functions, and I've also got all the images that I would like to be analyzing. All of these need to be saved in the same folder. If your images are not in the same folder that your MATLAB's current directory is, it's going to throw an error and not be able to run this. So I'm going to open up my particle tool. You can either double click it in MATLAB, the app itself. I'm just going to double click the app itself from the File Explorer in Windows. It's going to launch the app for me. And we'll see this user interface with all these parameters. The best way to get started is you can just click this Get Start Guide. It'll tell you a detailed explanation of how to do everything. I'm just going to go ahead and go in, and the first thing I'm going to do is just select an image. If I try and select an image from outside the working directory, it's going to throw me an error. It's going to say, hey, you selected an image outside the wrong folder. So I'm going to have to select one that in this default directory here. Maybe we'll start with these seeds. It's going to load that image into MATLAB and convert it into a binary image. It does not know the magnification by default. It's not smart enough to be able to read this off of the image itself. So the user has to manually input the magnification for each image you load in. In this case, it's 120,000. I'm going to go ahead and click Analyze and analyze it with the default filtering. We'll see what happens as it comes out with a histogram. This has all of the particles that were originally detected from the binary, and they're displayed here. This filtered particle uses this filter and this filter here. There's a filter for standard deviations, and there's a filter for the manual size, filtering out this by size. And maybe in this case, it doesn't make so much sense since there's so much uniformity to filter by standard deviation. I'll turn that filter off and redo this analysis, and we should see that these two histograms look the same. This is useful if you've got some kind of, maybe you've got some big stuff and some small stuff. We'll load it in a different image here. I see this one as a 30,000 mag. I'll click Analyze. I can see I've got some outliers here. Maybe I'll turn this filter on and redo the analysis quickly. And we can see it's going to throw out those outliers and just keep the one standard deviation of data. So that's kind of nice. Another thing you can do is filter manually by size. So I'm going to load a different image here. Maybe we'll load in this noisy cube sample here. Now you can see in the binary that it's going to have a problem. It thinks all of these are its own individual particles indicated by the white on the black. If I try and do an analysis here, I'll probably go ahead and change this to 160 because I know that that's the magnification. If I try and do an analysis, we'll see some interesting things happen. Oh, I think I missed the analysis button. Oh no, there it goes. It just was taking a second. I get a magnification warning. Now I use the right magnification, but it looks at the inner particle spacing and compares that to a known array value that you enter in. If they're significantly different, it gives you an error thinking that the magnification could be off. In this case, the magnification is correct, but it's just throwing this error because we've got so much background noise. Maybe I want to get rid of that background noise and try and measure this a little bit more accurately. In this scenario, what we can do is look at our main histogram, and we see that the particles that we care about are actually over here, whereas the junk is on this side. I'm going to change my particle filter to maybe be a minimum of 150. You can see my slider change correspondingly. I can't go maximum less than 150 now, which is kind of nice. And let's redo this analysis. So we're going to filter out all the particles less than 150, and we end up with something like this, where we just keep the particles that we're interested in. Now I can see that with my filtered particle size histogram, I'm keeping, and maybe since these are so uniform, maybe I want to turn off the standard deviation filtering and just keep all of this data. And there we go. We can see we have some very nice size uniformity. Standard deviation is just 3 nanometers. That's pretty good. We see that our inner particle spacing is actually very close to what is the known value, so that's also nice. You could change this, the inner particle spacing, how many particles it's using. It doesn't work so well for if there's a few particles on the image. You can see now my inner particle spacing is really high, and it's using the 5 nearest particles in the image. So these particles on the edge, it's counting the 5 nearest to them, and that might not make so much sense for images that don't have as many particles on it. Maybe if I load in an image that has a lot more particles, maybe we'll load in this hexagon one. We'll do the 30 magnification. If I load that in there, we'll see that with a lot more particles, we get a little bit more accurate average interparticle spacing. If I turn this down, we'll see that can impact it dramatically. So we get a lot closer with more particles. And if you're not have a lot of particles, maybe that's not the right thing to do. It defaults to 1. It just depends on what you're seeing. There's an option to use a neural network to denoise your data. You can enable that by clicking this, and that requires the neural network pack in MATLAB, the deep learning pack. So you can see in the raw image, my file is a little bit noisy, and actually I'll just go ahead and analyze this quickly. We'll see in the actual output file too, that we have a lot of noise in this image. If I denoise it with this neural network, it's gonna take a little bit longer. We'll see that in the loading time here, that it's gonna take a little bit longer. But we'll actually see a reduction in some of the noise right off the bat in the binary image, and the actual output image itself will look a lot cleaner too. So the neural network is actually very good for what it does. It gets rid of the noise pretty well. I like it a lot. It's useful for images that were scanned really fast. So you can see that cleaned this image up pretty nicely. We got rid of some of our popcorn, our background particles. We can see that I'm using the wrong magnification here because I'm not filtering out everything. So maybe we'll redo this with the correct magnification. I can turn this off to speed things up a little bit. One of the nice features is that you can export the overlay out as a PNG. So maybe I'll turn on the overlay, this thing, to output as a PNG, and I'll redo this analysis. Now it looks like nothing really happened, but I see an overlay pop up over here in my current folder. And if I go to that current folder, I can actually see that MATLAB has wrote this overlay to a PNG file. If you use the denoising too, that can actually clean up this PNG quite a lot, make it look a little bit nicer as well. So that's something that's interesting. Another thing that may be of interest is outputting data to a CSV file. So I'm going to select those seeds again. Now check this out. I've got my filter selected on 150. I'm going to put the right mag, 120. If I try and analyze this, it should throw me an error because I think that these seeds are smaller than my filter range. So yeah, again, no particles detected. We'll need to turn that back down, or you can just turn the manual size filter off completely. Maybe we want to do that for this kind of analysis. We're not doing really any filtering here. So I will select the image. This is just our seeds. They're 120,000 times. And this time I'm going to save that to a CSV file. So when I analyze these, I'll get all our relevant parameters. And notice that it's generated these 2 CSV files in my working folder, which is this one, sorry. And so one CSV is all the relevant final statistics. So this is things like the total size, the average size, the total number of particles you found, the filtered size. In this case, we didn't do any filtering, and yield for how many hexagons and triangles and things of that nature. That may matter if you're doing a hexagon triangle project, maybe not. Now, the nice thing about this is that I can close this out, and maybe I want to sequentially analyze something else. So that was this sample seeds. Then I grew it for an hour in CTab, and I see it's at 120K, so I'll analyze it again. Maybe I want to do 2 hours. That's also at 120K. We'll analyze it again. How about 3 hours quickly? So 3 hours, this one's at, I believe, 30,000 actually. So we'll switch it to 30,000, we'll analyze again. Now what we can do is go in and take a look at that final statistics file again. Oop, it's kicked me out because it was still finishing its analysis. Let me go look at the file. And we'll see that it actually adds a row to this final statistics for each analysis that you do. So that's very nice. So this was my 0, 1 hour, 2 hour, 3 hours. You can see my average size is getting bigger and bigger, and my hexagon yield is changing as I do this. This is very nice. This is a very nice way to pull out data. Maybe you downloaded like 10 SEM images, they're all high magnification for the same sample, and you want to kind of combine all their data together. This would be a quick way to do that. Maybe you've got some kind of sequential growth you're doing. This would also be a quick way to do that. It's worth noting that the second file that gets output is just the raw data from the very last analysis you did. So it just shows all the actual raw data from the very last analysis. It has things like the diameter, circularity, eccentricity, area, perimeter, orientation, orientation and the centroids. This could be useful if you wanted to be doing a more thorough analysis with your own parameters in Microsoft Excel. It's worth noting that this gets overwritten every time. So it does not add, it does not concatenate things at the bottom. It does not add the particles to each one. It just contains just the data, the raw data from the last one. Whereas the actual statistics file adds a row for each analysis you perform. So let's go look back at our app tool. So if I wanted to here, maybe I could turn some filtering on. You can see that it's categorizing our triangles and our hexagons and our irregular and 3D particles. It does a pretty good job. And actually, I've just thrown an error here. I'll try and fix that. Let's see. Unable to, so if you've got the file open in Microsoft Excel, you're going to get some interesting errors. So I could probably figure out how to make them not error, but I'm kind of lazy. So if you're trying to write to the file that you already have open in Excel, it's going to be a problem. So you might have to exit some of these and click analyze again, and this time it should actually be able to do it correctly. So there we go, we filter out our data. We've got our image here. It's worth noting that the smaller SEM images, the machine vision to detect the particle shapes, it's not as good as the images get more and more zoomed out. The smaller and smaller the triangles appear to MATLAB, the harder it is for them to accurately detect them. Whereas these more zoomed in images, it's easier for it to be able to tell what is what shape. So that's worth noting, just something to keep in mind. It has a lot better time identifying shapes in this scenario. I think that's about it. So hopefully this helps you. You can play around with the array sample and then you do all these different filters and different options, and let me know if you have any questions. Hopefully that helps you get started using this tool. Thanks.